Hello and welcome to Miss Ma's Grade 11 Functions class. This is 4.4, Simplifying Algebraic Expressions with Exponents. So we're going to simplify by just trying to get rid of all the negative exponents and putting all the things together. So just use the power rule first. And don't forget to multiply everything, including your coefficient, by the power. So we're going to get this right here. I just multiplied them all out. And then I'm going to use the quotient rule. So, well, 2 cubed is just 8, so I'll just leave that alone. I'll evaluate it. If you have numbers and the exponent is kind of low, you could just evaluate it. That's usually better. 6 minus 8, so I'm just using the quotient rule. Actually, this should be 6 minus negative 8, so I'm just going to put a plus there. So this becomes 8 to the times x to the negative 15 times y to the 14. And remember that if you have a negative exponent, it's unhappy where it is. It wants to go to the top or the bottom. If it's in the top, it'll go to the bottom, and if it's in the bottom, it's going to go to the top. So I'm going to just move that to the bottom and keep everything else the way it is, and that is our simplified expression. You can give it a little victory dance of completion. Done. Okay. And this one we might need to evaluate something. So the first thing we might want to do is actually to add everything together and do it that way. So just use the rules, product and quotient rules. So I'll get x to the 2n plus 1 plus 3n minus 1 minus 2n minus 5. And don't forget to use your distributive property when you use the negative. So I'm going to get x 2n plus 3n minus 2n is 3n, and 1 minus 1 plus 5 is plus 5. So I get x to the 3n plus 5. That's in its simplified form, and now it says evaluate for this number. So we get x is 2, and then we're going to put 3 times negative 5 plus 5. I just put the numbers in where we need to. So I'm really doing 2 to the negative 10, because negative 15 plus 5. And of course we know that this is really 1 over 2 to the 10, and if you know your powers of 2, you'll know that that is 1 over 1024. Okay, and there you go. That's the answer. Alright, so this is just another one, and we've got a fraction in there and a decimal, and you don't have to worry about that. That's still going to be multiplying in, so don't get too concerned. 27 to the 1/3. And remember, the third means it's the cube root, so what times itself 3 times is going to be equal to 27. And you just multiply these out. Negative 1, 12 times 1 over 3 is b to the 4. And in the bottom we'll do the same, so it's going to be 16. And I'm actually going to convert this to be a fraction, which is 3 over 4. So 16 to the 3 over 4, a to the negative 6, b to the 3 times 3 is 9. Okay, and just like before, we're going to collect the like terms for the a's and the b's, and with the numbers I'm going to evaluate them. So 3 cubed is 27, so I know this is going to be 3. A minus 1 minus negative 6. B to the 4 minus 9. And in the bottom I've got 16 to the 3 over 4. I know 16 to the 1 over 4 is equal to 2. And so 16 to the 3 over 4 is like 2 cubed, which is 8. Okay, so we put 8 in the bottom. And we'll just collect these numbers together. So we get 3 times a to the negative 7, b to the negative 5 over 8. And these are both negative, so they're going to go down to the bottom. 3 over 8, a to the 7, b to the 5. And you just want to put them in alphabetical order. And there you go. Alright, find m. Okay, so now we're going to work on the principle, basically, that if you have the same base, like let's say 2 to the x plus 1 is equal to 2 to the 4. So you can see that these 2's are the same, they have the same base. If they have the same base, then they have the same exponent, so I can just say x plus 1 is equal to 4. So in this case, x equals 3, just solve it, right? So that's how you do this type of question. So basically what we want to do is we want to figure out this so that this is a base of 3. In 729, you can just keep multiplying 3's together until you get to it. It should be 3 to the... I'm thinking about it. Well, I know it's actually... Let's figure it out. It's 27 squared. And 27 is 3 cubed, so this is 3 cubed squared, or in other words, 3 to the 6. So that is how I'm going to figure out what my answer is. I just write the things on the side. And this is my side work. And don't let it be equal down here. So this is going to be, I'm going to just use a different color here, 3 to the 6 equals 3 to the 2m minus 1. And so 6 equals 2m minus 1, and then I can just solve for it. So 7 equals 2m, and m equals 7 over 2. And that's how I find m, like that. If it's not possible to get the bases to be equal, then it's not solvable for now until we learn about logs when you get to grade 12, so you don't have to worry about them. But so in theory, you should always be able to get the same base in these questions. Okay, so example E, we've got all letters, which means that we don't really have to worry about making it the same base because we're going to get x, but we do need to make sure I have one x on this side and one x on this side. So I'm just going to simplify each side first, and then I can let them be equal. So you're just going to use, well, you could use whichever rule you want to use first. I'm just going to use the quotient rule first here, and the power rule on this side. So they're multiplied together. And I'm going to simplify that using the distributive property. So 12m minus 28, I just also change the order so that it'd be standard form, and this is going to be 3m squared minus 12 minus 5 is negative 17m plus 20. Okay, you could do the algebra on your own. If you find it difficult, you could just pause the video and figure it out on your own first. And so because I have x on this side and x on this side, I can just let these be equal without the x's at all. And now you can see it's just a regular quadratic like we've been doing in grade 10 and also in chapter 3. So we'll just move everything over, 3m squared minus 29m plus 48, and we'll solve it. I happen to know that it is not factorable, so I'm going to use my quadratic formula. Don't forget to write the quadratic formula throughout. If you decided, okay, I'm going to forget the quadratic formula for the rest of the course until the exam, nope, you're going to need it quite a bit, so make sure that you keep it. 29 plus minus 29 squared is 841, minus 3 times 4 times 48, which is 576, over 6. And that ends up being 29 plus minus the square root of 265, I believe. I'm just checking my notes. 265 over 6, and that's not factorable, so that is the answer. Okay, so I just found m. Alright. Now this one, it's very similar, but now we have to find the x which is in the exponent, so it's just like example D that we did before. So here we have to have the same power as this, but we do know that a 4 is 2 squared, so we're going to just change that to be a 2 squared. So this becomes 2 squared on the inside times x minus 1, or sorry, to the x minus 1, and then I can multiply it for the power rule and write it like this. And you shouldn't skip this step because, it's not necessarily obvious to everyone. Now that we have the same base, we can let them be equal. And then solve it. It's just a regular linear algebraic equation. So move one side over and we get 5 equals x, like that, and that's our answer. Okay? So for this one, again, we don't have the same base, but we want to make it into the same base. We know that we can never get 3 to the something equals 0, right? So that means that this is not possible. So there is no such x is what we would write. There is no such x. 3 to the something will never be equal to 0. So if you can't have the same base, then it's not possible, and you can just write that in as such. For this one, this is a little bit tricky. We've got 2 to the x plus 1 plus 2 to the x equals 48. So we want to actually get rid of this plus 1 here. And how we're going to do that is, if you remember, so 2 to the 1 times 2 to the x is actually equal to 2 to the x plus 1, right? So I'm going to do it that way. I'm going to go 2 times 2 to the x plus 2 to the x is equal to 48. And you might notice that we could common factor that out now. I've got 2 to the x and a 2 to the x here. So I'm going to common factor out the 2 to the x. It goes 2 to the x times, and then whatever's left, 2, this is a 2, plus, and this is 2 to the x times 1, so 1 equals 48. Don't let that be a 0 because that's not how you do it. 2 to the x divided by 2 to the x is 1. So I get 2 to the x equals 3 times 3 equals 48, and I can divide that out. 2 to the x equals 48 divided by 3 is 16, and I know 16 is really 2 to the 4, so x is equal to 4. And there you go. The next one. So again, I've got all these different bases, but I know that they're all powers of 2, so I'm just going to make them into powers of 2 here. So 8 is 2 cubed. 4 is 2 squared. And 16 is 2 to the 4. So again, we can just simplify that out once we figure out the little trick there. So this becomes 2 to the 3x plus 6 over 2 to the 2x plus 6 equals 2 to the 4x minus 12. Again, make sure you use the distributive property. And then I'm just going to subtract these, so I get 1, 2 in the bottom as the base. So 2 to the 3x plus 6 minus 2x minus 6. Don't forget to distribute the negative in there. 2 to the 4x minus 12 on the other side. And we can simplify it. So again, don't skip the step, even though it's really tempting. I'm tempted to do it right now. So 2 to the x equals 2 to the 4x minus 12. And we're going to now set them to be equal. And we will solve. I need to extend the page there. So move 1 over, so I get 3x equals 12, and x equals 4. And there we go, we solve for x. Alright. Now this is, I think, the last one, and it's definitely the most complicated to think about. So the key here is that 2 to the 2x is basically the same as 2 to the x squared, okay? Which is also the same as 2 squared to the x. But this is the one that we really care about. Why? Well, because we're going to write this as 2 to the x squared minus 12 times 2 to the x plus 32 equals 0. And the reason we want to do that is because then we can think of 2 to the x as another variable. So if I want to write on the side, let's say I'm going to say, okay, 2 to the x is equal to, and you can choose any variable, m. Now, wherever I see 2 to the x, I can replace that with m, right? So 2 to the x is here, and 2 to the x is here. So I'm going to write m squared minus 12 times m plus 32 is equal to 0. And you can see now this has become a quadratic, and I can just solve for it. 32 is 8 times 4, so this is m minus 4 times m minus 8 is equal to 0, which means that m is equal to 4, or m is equal to 8. And then I can take that m, and I'm going to replace it again with the 2 to the x, so that I get 2 to the x equals 4, and 2 to the x equals 8. And of course we know that 2 squared is 4, so x is equal to 2 in this case, or 2 cubed is 8, so x is equal to 3, and that's how we find our answer. So this is definitely the most complicated type, but you can always look out for this 2x here, then you know, okay, that's what I've got to do. Alright. So we had a few different strategies in this lesson. We did making the same base and then equating the exponents. We did take out the plus 1 So like 2 to the x plus 1 minus 2 to the x, for example. Take out the plus 1 and then common factor out the 2 to the x. And then we did replacing 2 to the x with a number to solve a quadratic. So those are some of the techniques that we use to solve exponential equations. I hope that you enjoyed it, and thanks for watching.